Okay, guys, welcome back. Today, inshallah, we're going to continue section 4 of chapter 4. We're still talking about the metamorphic rocks. Yesterday, we just get the first 2 pages in our lesson. We know what are the origins of metamorphic rocks, and we know also how the metamorphism process happens. So let's remember what we studied last time. Who can remind me what are the origins or what are the origin of metamorphic rock, guys? Yes, Nano?
Any other rock like sedimentary or igneous?
Excellent. Any other rock, sedimentary or igneous, or even a metamorphic rock, okay? So any type of the three types of rocks, could it be changed into metamorphic rock? The question is how these rocks could be changed into metamorphic rock. Yes, Maya?
By heat and pressure.
Yes, once they exposed to extreme heat and pressure, they could change or their structure, texture, or even the composition could change completely and turn into a new rock. Okay, and we said what we call the process of this changing, what we call this process. Who can tell me? Okay, anyone else? Yes, Hannah Hamdi.
Metamorphism.
Metamorphism, excellent. So we metamorphism, we said that the change that could happen in texture, structure, or even the composition of a mineral, so of a rock, sorry, we call this metamorphism. Then we studied that there are 2 types of metamorphism. Who can remind me what are the 2 types of metamorphism, guys? Yes, Kinsey?
Connect metamorphism and the original and original.
Original, not original, original, okay?
Original.
Yeah, so we have 2 types of metamorphism, contact metamorphism and regional metamorphism. Who can remind me what is contact metamorphism, guys, or how contact metamorphism could happen? Yes, Judy?
It's when the magma moves into the crust up,
Yep.
and it's surrounded by rock,
Yeah.
where it causes change.
Yeah, so when magma passes in the rock, as you can see here in the picture, the rocks which in contact, or the rocks that surround the magma and in direct contact with magma, they will be exposed to extremely heat and pressure, so they will change completely into a metamorphic rock. So we call this contact metamorphism. What about regional metamorphism, guys? Who can remind me what is regional metamorphism? Maya?
Uh, regional metamorphism occurs when pressure builds up in rock that is buried deep below the rock formation.
Good. We said that because of the rocks movement, or we said that the some movement of the Earth's crust. Okay, it may cause a lot of pressure. Okay, under on the layers of the rock which already buried underground. So here, this high pressure could change or could make this rock change into a metamorphic rock, and we call this regional metamorphism. So let's compare between contact metamorphism and regional metamorphism. Which one of them, guys, has more effect on rocks? Contact metamorphism or regional metamorphism? Yes, Judy?
Contact.
Yes, contact metamorphism, because the rocks will be in direct contact with magma, so they will be exposed into to extremely heat and pressure, so they will change completely, or they will form a new metamorphic rock. While here, okay, the regional metamorphism, it has a slightly, or that's the effect is not that much like magma, because it doesn't expose to that extreme temperature, but it's exposed to high pressure, so they change, but not like the change that happened in contact metamorphism. So the contact metamorphism has intense change or intense effect rather than the original metamorphism. But here in case of contact metamorphism, we could find that the change just limited to the rocks which already surround the magma, while the other rocks, they don't suffer from any change, or they don't, okay, have any change. But in regional metamorphism, we find that the effect of the pressure could extend to many kilometers, okay, on the layers under the ground. So here we have, this one has extreme effect but limited area, while the regional metamorphism has less effect but large area. You get this, guys? Is it clear?
Yes.
Yep.
Yes.
Okay, today, inshallah, guys, we're gonna pass to the new part of our lesson. So we're gonna talk about the composition of metamorphic rocks. So once we talk about composition, we know composition of a rock depend on the minerals which are already found in a rock. We studied this before, as we know that any rock is made of mixture of minerals and some organic materials and so on. So here in that case, we said that composition of metamorphic rock, the metamorphic rock already originated from other rocks. So do metamorphic rock will keep the same composition of the original rocks they made of? That means if I have sedimentary rock and this sedimentary rock exposed to heat and pressure, do the minerals which found in the sedimentary rock will be as it is or they will change? What do you think?
They will change.
Yeah, they will change because of the effect of heat and pressure. Always remember the example which we said about the cookies yesterday. The components, okay, they completely changed after we put them in the oven. Do you remember this, guys?
Yes.
Yeah. So here like this,
Yes.
also we said that in metamorphism or once metamorphism process, the first change happen. So pressure, extreme pressure and temperature inside the earth, they may change the structure of the minerals which found in the rock. Because of this high temperature and the pressure, the minerals will not be stable. So they will break down or they will gonna form a new minerals which are more stable. You get the idea, guys? Yeah. For example, let's take an example. Look here. Calcite, quartz, and hematite, all these are minerals. We know them before. So once these minerals are already exposed to heat and pressure, that means the factors which cause the process of metamorphism, we find calcite, quartz, and hematite, they are gonna break down and they will form, okay, a new mineral which is garnet. So garnet is a mineral that could only found in metamorphic rock. I cannot find it in another rock. Okay, why? Because garnet to be produced, it needs the combination of three minerals under extreme heat and pressure. Is it correct, guys? And this extreme heat and pressure cannot be found on the Earth's crust. It must be found deep, okay, or deep under long depth of layers of Earth crust. Is it clear, guys?
Yes.
Yeah. So I need someone here to read this paragraph, okay? So, Fadia, could you read this part, composition of metamorphic rock? Look, okay, Nano?
Metamorphism occurs when temperature and pressure inside the Earth's crust change. Minerals that were present in the rock when it formed may not be stable in the new temperature and pressure conditions. The original minerals change into minerals that are more stable in these new conditions. Look at figure 3 to see an example of how the change happens.
Yeah, thank you.
Many
Just at this point, so here that the idea that this rock, okay, calcite, quartz, and hematite, for example, once they are under extreme heat and temperature, they will not be stable. They will break down and recombine to form a new mineral. Okay, so once I said we have a mineral, we have a rock that contain garnet mineral. So like this, we know that rock must be what kind of rock that contain garnet mineral?
Metamorphic rock.
Must be metamorphic. Can it be another type of rock?
No.
Can it be sedimentary or igneous?
No.
No. Why? Because garnet just formed of the combination of three minerals under extreme heat and pressure. So these conditions only happen in case of metamorphism process. That means during formation of metamorphic rock only. You get this, guys? Is it clear?
Yes.
Yep. Okay. So here, then I need another one to read the rest of the paragraph. Okay. So yes, Hannah. Starting from many of
Many of these new minerals form only in metamorphic rock. As shown in figure 4, some metamorphic minerals form only at certain temperatures and pressures. These minerals, known as index minerals, are used to estimate the temperature, depth, and pressure at which a rock undergoes metamorphism. Index minerals include biotite mica, chlorine, garnet, kyanite, muscovite mica,
Muscovite mica.
uh, muscovite mica, sillimanite, and sterolite.
Light. Good, very good. Okay, so here, guys, anyone get who can tell me what the idea of this paragraph? Okay, what means by index mineral, or what is the index mineral? Who can tell me what you understood from these guys? Hey, rest of people, guys. Jaina, Fadia, Rashwan.
Mr. Fadia left the meeting because she can't hear الصوت مش باين عندها.
Okay, other people, guys. Okay.
What's the question?
Again, we said here, what you understood, what mean by index mineral? We said that here, as your friend said, we said that index mineral, they're just some minerals which are found in metamorphic rocks only. So what do you get? What this index mineral are important? Look at this figure, okay, and it may help you to figure the idea. Let's try to share your ideas, guys. Yes, Rashwan.
They're used to estimate the temperature and pressure at which rock undergoes metamorphism.
Somehow, yeah, okay. Could you explain more, or just that what you understood?
And they include biotite mica, chlorite.
I don't ask about examples. Here, look with me, guys, to understand what the meaning. As you can see here, for example, in this figure, he gave you some minerals: chlorite, muscovite, mica, and granite. They are minerals. Each mineral, or each one of these minerals, it's already formed at certain degree, okay, or a certain temperature, and then certain depth, which represent, as we go down, of course, the pressure increase, because here, once we are and from 25 to 60 kilometers, okay, under the ground, it means we have a lot of layers above, so we have higher pressure. So as we go down, we get more pressure, of course. So like this, if you get a rock and you find that rock already contain chloride, so you could expect that this rock already formed at which temperature? Hey guys, again, if you get a rock, okay, a metamorphic rock, and you find this rock contain chloride mineral, so do you expect, or what the expected temperature in which the rock is formed at?
High temperature.
Which exactly which temperature? It contains
400.
400. Good. Okay, so that means you already know the temperature which the rock is formed at, because it contains a certain mineral that you know it just formed at 400 degrees Celsius. Yes or no? So
Yes.
this mineral help you to estimate the pressure and the temperature, or even the depth in which the rock is formed. Yes or no?
Yes.
So for example, if you get a metamorphic rock, I give you a sample of metamorphic rock, and you find this metamorphic rock contains garnet mineral. So it exposed, or you exposed that we find this rock at depth equal. How much the depth could be? And if we found a metamorphic rock that contain garnet mineral?
25 to 60 kilometers.
Yes, it's between 25 to 60. That means it never could be, okay, less than 25 kilometers. Yes or no?
Yes.
Yeah.
Yes.
Like this, we call these index minerals. Index minerals, they are minerals that help us to estimate, to predict the temperature, the depth, and the pressure in which the rock is formed. You get this, guys?
Yes.
All
Yes.
these index minerals, they already formed from other minerals that they already combined together because of the extreme pressure and temperature. Okay, so that means this mineral is just exclusive for metamorphic rocks only. I cannot find them in another types of rocks like igneous or sedimentary rock, just found in metamorphic rocks, because they already formed because of the extreme heat and temperature. Is it clear, guys?
Yes.
Yes.
Yeah. So like this, that also could help scientists to predict how the Earth look like. That means, okay, once I find this kind of rock and I predict what the changes that happen at which temperature and which depth and so on like that, I could predict how the temperature look like at certain depth. For example, that mean at 60 kilometers, that means the temperature just be from between 700 to 1200 degrees Celsius. So that give us expectation about the temperature. Of course, we cannot measure this temperature down on the earth, okay, easily. So that will be a just simple way to figure out how the earth look like deep underground. So that's the importance of the index mineral that give ideas about how the rock is formed, what the conditions it's formed at, and how the earth is, okay, or how the earth under the under the earth's crust look like. Is it hard, guys? Any hard question here?
No, thank you.
Okay, so then we'll pass to the next part. Okay, here we talk about the texture of metamorphic rock. As we studied before, we know that we classify rocks generally, whatever the type of the rock is, sedimentary, igneous, or metamorphic. We classify depend on the composition and structure and texture. As we already studied the composition, and we know that the composition of the metamorphic rock differ than the composition of other rocks because already they will expose to high extreme pressure and temperature that lead minerals to change into special and new minerals just found in metamorphic rock. Now we have another thing, the texture. What about the texture of the metamorphic rock? We studied the texture in igneous and sedimentary rock, and always we said that the texture should be fine grained, medium grained, or coarse grained. Do you remember this, guys?
Yes.
Who
Yes.
can remind me what difference between fine grained texture and coarse grained texture? Yes, Rashwan?
Can you repeat the question?
Again, what's the difference between fine grained texture and coarse grained texture? Okay, Judy?
A fine grained texture when the rock is يعني cooling rapidly يعني
That's for example in igneous rock, once it cool rapidly, yes, what happened to that
it
size?
forms the large rocks.
It's form fine rock, so that means it will be smooth, yes or no? So fine grain
Yes.
means the size of the particles or the crystals or okay or the grains, they are too small, so they appear to be smooth. While coarse grained, it means it will be
Slower in cooling يعني وform where it will have a rough texture.
it's yeah, rough texture. So fine grain means smooth and coarse grain means rough texture. So that's usually we classify rocks at, okay, but in case of metamorphic rock, as the composition will change, as already the minerals will not be the same like in sedimentary and igneous rock, we're gonna have new minerals. So also here we're gonna classify the metamorphic rocks regarding to their textures into two categories: foliated and non-foliated. Okay, so we have foliated metamorphic rock and non-foliated metamorphic rock. Okay, so what is foliated texture or what is foliated? Okay, so we see that foliated, the texture of metamorphic rock in which the mineral grains are arranged in planes, okay, or bands. That means we are gonna find that the grains, they have certain arrangement, okay, they have a specific arrangement, okay, so they appear to be in bands or in planes. So we call this foliated. You get this, guys? Do you know, like when you arrange your books and you put it, okay, the large one, then the smaller, so it appears to be in plans, okay? Or once you just wrap your pencils and your colors, okay, by elastic band, okay, you make them in bands like this. So that's also means foliated. You get this, guys? Okay.
Yes.
Yeah, so here that's mean. So I'm gonna draw it for you to just to clarify the idea. Here, look with me. That's mean here, guys, we are gonna find that the grains, they could be arranged in bands. That means the grains, they just be arranged like that in bands. They are grouped. So if you look here, you are gonna find they seem to be okay in groups. Yes or no? You get this? Okay.
Yes.
Yes.
Or they could be in planes like this. Okay. So they appear to be in plane and so on. So in that case, that's mean, okay, their grains already have a specific arrangement, okay, in planes or in bands, which make them, okay, have some kinds of organized way organized appearance. So we call this foliated texture. We call this foliated texture. Any other question here, guys?
No.
Okay, so I need someone to start reading this part, this paragraph, foliated metamorphic rock. Okay, Fadia. Fadia, can you hear me right now? Okay, what about the other people, guys? Hey, other people, please. Reem, Regina, Hannah. Okay, Judy, read, please.
The texture of metamorphic rock in which the mineral veins are arranged in planes or bands is called foliated. Foliated metamorphic rock usually contains aligned grains of flat minerals, such as
Biotite mica.
biotite mica or chloride. Look at figure 5. Shale is a sedimentary rock made of layers of clay minerals. When shale is exposed to slight heat and pressure, the clay minerals change into mica minerals. The shale becomes a foliated metamorphic rock called slate.
Good.
I continue?
Yeah.
Metamorphic rock can become other metamorphic rocks if the environment changes again. If slate is exposed to more heat and pressure, the slate can change into a rock called phyllite.
Good.
When phyllite is exposed to heat and pressure, it can change into
Just.
I'm sorry بس عمال يعمل join وريجوين كل 1 second.
What Regina again?
I'm sorry بس يعني عمل يعمل join وريجوين كل 5 seconds.
Okay.
مش عارفة أتكلم خالص.
Okay, no problem. Yes, continue.
الإنترنت عندي هتقفل.
Okay.
If metamorphism continues, the arrangement of minerals in the rock changes. More heat and pressure cause minerals to separate into distinct bands into a metamorphic rock called nice.
Okay, yes. Okay. So here, guys, look to this idea. Here, we know what's foliated metal. That's about the texture. So look here, that represent you change between different types of rocks, okay? Or between different rocks. So here we have sedimentary rock. That's shale is already sedimentary rock made of sediments, as we know, and the sediments already cemented together, whatever the material did to stick them together. Once this sedimentary rock exposed to slightly heat and pressure, that means that pressure and heat is not that much. But this heat and pressure is enough to change this sedimentary rock into a metamorphic rock. We call it slate. If you look at the slate, guys, you're gonna appears to be have a layers or appear to have a band like this. Could you see it?
Yes.
Yes. Okay. So that is a foliated metamorphic rock. Okay. If the slate keep exposed to pressure and temperature, okay, or high pressure and temperature, it could change into another metamorphic rock. That means this is metamorphic rock and that is another metamorphic rock. So what the changes happen here, the difference in temperature and pressure, or the extreme pressure and temperature, cause the structure or the composition of slate to change. That means the minerals in slate somehow changed, okay, into another minerals, cause formation of a new rock, which is phyllite, okay. Then here, if phyllite also keeps exposing to pressure and temperature, it may change also into chest. Here in chest, it appears to have the bundles. Do you see the bundles, guys? Okay.
Yes.
Yes.
Then if chest still keep exposing to. Here the texture doesn't change, but what changes is the composition. Okay, all these are metamorphic rock. All of them, they are foliated. Okay, because as we can see that their minerals, they already arranged in planes or bundles, but the composition is changed from one to another depending on the effect of heat and pressure they exposed to. Is it clear, guys?
Yes.
Any hard
Yes.
regarding to this part? Any hard question here, guys?
No, thank you.
Okay, guys, that's the part which we're gonna stop at. Next time, inshallah, we're gonna continue our lesson. So please study this part very well. And if you have any question, I'm waiting for your question next time, inshallah. Thank you. Goodbye.
Bye.